Hello and welcome back. We'll continue looking at hypothesis testing involving proportions. And one thing I do want to reiterate is how to find the p-value before we do one more example. So if we're doing a left tail test like we were in the last one, when the alternative hypothesis is written as p is less than some number, the p-value is the area to the left of the test statistic. So for instance, if our test statistic was here, then our p-value is going to be the area to the left. It will simply be this area over here. And this area is the p-value. Now, we could have an alternative hypothesis that looks like p is greater than a number, which means that we'll have a right tail test, and typically the z-score there will be above 0, and we'd be looking at the area to the right of the z-score, and this will be your p-value. There is one final way of writing, one final form for the alternative hypothesis. We could say that the proportion is less than a number, the proportion is greater than a number, or simply that the proportion is not equal to a number. And this is the only time that we'd really have to be a bit careful with how we phrase this. The p-value is going to be equal to 2 times the area of the extreme region. And what does the extreme region mean? Well, if our z-score is negative, so here's 0, if here's our z-score, we want a two-tailed test. So if here's our z-score, we can clearly see, okay, this is going to be one tail, but what is the other tail? Well, if we take this same z-score and just flip it over, because this whole thing is symmetric, we want to add this tail back. Now, how do I find the area of this tail and this tail? They're the same. So whatever this area is, if I take it times 2, that's the combined area of both of these. So when we have a z-score that's below 0, the p-value is twice this area, twice the area, because it'll just be the same thing on the other side. If we have a z-score that's positive, it shouldn't reach 0, but oh well. If we had a z-score that's positive, again, we can see that, okay, so this is going to be one tail. That's pretty clear. The other tail should just be on the other side, and it should be the same size since the normal distribution is symmetric. So again, the p-value, we take this and we take it times 2. So when we have a two-tailed test, we find the p-value like we normally would, just the area to the left or right of the value, just whichever side it's on, and we take it at times 2. So let's look at an example. I flip a coin 100 times and I get 58 heads. So the question is, can I claim that the coin is unfair? And by unfair, I mean that the probability of flipping a heads is not 0.5. So we want to use a 0.05 significance level, and we want to test this hypothesis. So the claim is that the probability, or maybe I'll phrase this in terms of proportion. The proportion of heads that would be flipped by this coin is not 0.5. So I would argue that this, so I feel that this coin is not fair. I flipped 58 out of 100 heads. That seems like I'm flipping more heads than tails. So I'll claim that the coin is unfair. Now, symbolically, this would mean that the proportion or the probability that we flip a heads is not 0.5. So let's test this hypothesis. Let's test this claim. So the null and alternative hypothesis. So we have H0 and H1. H0 is going to be, the probability is in fact equal to 0.5. And H1 is going to be the probability is not equal to 0.5. So again, the null hypothesis is when we say that the probability is equal to that value, and the alternative is when we say that it's not equal, or greater than, or less than. In this case, it's just going to be not equal to. Our significance level, we just had alpha is going to be 0.05, just like a standard significance level. And now for our test statistic, again, we'll be using a z-score. We have p hat minus p divided by the square root of p times q over n. P hat is our sample proportion, and that was 58 out of 100. What we're testing against, our claim is going to be 0.5, and Q, which is going to be the percentage of failures, will also be 0.5, and N, well, we flip the coin 100 times. So this is going to be 0.58 minus 0.5 divided by the square root of 0.5 times 0.5 divided by 100. Plug this into a calculator, and we get 1.6. Cool. So we need to find our p-value, and so I like to graph this, and we'll see what our p-value should be. So our test statistic is 1.6, which will be up here. And our alternative hypothesis is that p is not equal to 0.5. So it could be greater than or less than, which means we are doing a two-tailed test. So clearly, this is going to be one tail. So the p-value is going to be twice this area here. So we come to StatCrunch, we open up our normal calculator, and now we want to find the area that's greater than 1.6. So we get 0.0548. So our p-value is going to be equal to twice 0.0548, which will be in fact 0.1096. So here's our p-value. Cool. So we found our p-value, and now we can compare this to our significance level. So our p-value, which is 0.0196, and if we compare that to alpha, which is 0.05, our p-value is bigger than or equal to alpha. So our p-value is the probability that we get the sample given our null hypothesis. So our p-value is bigger than 0.05. So this doesn't seem very unusual. There's a 10 or maybe closer to 11% chance that I could flip 58 heads or more, or more extreme, on a coin. So we would fail to reject the claim that the probability of flipping a heads is 0.5. In this scenario, flipping 58 heads out of 100 doesn't seem all that unlikely. It would happen, so we would flip either 58 or more heads, or down below, because we're looking at a two-sided distribution, about 10% of the time, and that doesn't seem all that unusual. So what can we say? How can we conclude this? So we'd say that there is not sufficient evidence to claim the coin is unfair. So ultimately, flipping 58 heads out of 100 doesn't seem all that unusual. So even though 58% is bigger than 50%, we only flip the coins 100 times, and maybe we'd need to flip the coin 1,000 times before we would be more sure that the coin is unfair. And I will do one more video where I go through and I look at how to do all of this very quickly in StatCrunch.